Now, it turns out our eardrums can only register a certain amount of wiggles per second. And the lowest range we can hear is something that moves back and forth 20 times in a second. So we can't hear this. But if I could move fast enough that this was moving 20 times per second, you'd hear a low pitch. And that's pretty cool. Our eardrums don't register sounds that wiggle back and forth over 20,000 times per second. When they move faster than that, they go out of our hearing range. Dogs can hear that, but we can't. We can only hear a certain amount of fluctuations, a certain amount of wiggles, a certain amount of oscillations per second. And that is as low as 20 times per second and as high as 20,000 times per second. That's the range of our hearing. Now, of course, that wiggle is the movement of the vibration of the thing that vibrated, is received by our eardrum, and then it goes into our brain, and it becomes an electrochemical process. Now, I'm not going to cover that because, to be quite honest, I have no idea how that works. As far as I'm concerned, that's crazy witchcraft. But in some way, vibration is converted into electrochemical energy in our brains. So, how many times a thing wiggles per second is important because that defines frequency. Now, frequency isn't just how many times it wiggles back and forth per second. Frequency is also something else to us, and that's pitch. If I had a tuning fork here, and it was an A tuning fork, let's say it was A440. A440, which sounds like some confusing designation, but it's just saying that that piece of metal wiggles back and forth 440 times in a second. That's what pitch is. It's just how many times it wiggles. How many times it goes back and forth, that's its pitch and its frequency. Now, pitch is limited to our hearing range. There aren't pitches that really we can't hear because we stop calling them pitches when they're out of human hearing range and we just call it frequency. But the point of the matter is, A440, that's 440 wiggles per second. Ding, that's sound. The other thing that we haven't talked about yet is amplitude or volume, which is how hard a thing wiggles. So if you flick a hair, it's tiny and it doesn't wiggle very hard. Compare that to banging a trash can lid. Obviously, it's willing to wiggle very hard. So if we think about waveform, remember we were talking about waveform? A waveform that doesn't wiggle very much is a quiet sound. So if it's just a slight back and forth movement, that is a quiet vibration. Something that wiggles just slightly doesn't make a big noise. Something that wiggles a great deal makes a loud noise. So when you hit a cymbal, you can see that cymbal going, that's a loud noise. And that's amplitude. It's a big wiggle. The bigger the wiggle, the more amplitude, or to our ears, the louder the sound is. So frequency is how many times the wiggle happens per second. And amplitude is the degree to which the wiggle wiggles. Like whether it's a big wiggle. Irrespective of how fast it wiggles, if it wiggles big, it's a loud sound. See, this stuff is just not complicated at all. It all can be described in a wiggle.